Okay, so in this video I'm going to be going through the final review. The first few questions on the first page want me to graph piecewise functions. It gives me a function and then defines it. So my first part is f of x equals 2x plus 3 for x is greater than or equal to negative 2. So what we're going to do is we're going to plug in points on these equations for them. We're going to split it up into two different equations because there's two equations up here. On the first one, I'm going to plug in negative 2. So I'm going to have 2 times negative 2 plus 3. 2 times negative 2 is negative 4 plus 3 is 7. So I plugged in negative 2. I got out 7. I'm going to do the same thing for negative 1. I have 2 times negative 1 plus 3. 2 times negative 1 is negative 2 plus 3 is 1. So I plugged in negative 1. I got out positive 1. Then for 0, I am going to plug that in. 2 times 0 is 0, plus 3 is 3. So 0 gives me 3. Then I have my second equation I use if my x value is less than negative 2. I am going to... Why are the colors off? There you go. On this one, I'm going to plug in negative 2 again. So I have negative 2 plus 2. Negative 2 is positive 2 plus 2 is 4. Then my next one, I'm going to plug in negative 3. Negative 3 plus 2 is 3 plus 2. So I get 5. And then my next one, negative 4. Plus 2. Negative 4 is positive 4, plus 2 is 6, so negative 4, positive 6. I'm going to go ahead and graph these. I want to pay close attention to which one had the line underneath. That was my top equation, so this is the point that gets the closed circle. So I'm going to go to negative 2. positive 7. 1, 2, 3, 4, 5, 6, 7. That one gets the closed circle. Then I'm going to go down to negative 1, 1, and then 0, wait a second. My first point I got wrong. Negative 2 plus 3 is negative 1. I apologize. So I'm going to go to this point right here, and I'm going to ignore this top point. Then 0, 3. Okay, because it's greater than, this is going to go right forever. So I want to connect my points starting at my final dot. My next one, I'm going to graph. This one's going to get an open circle. So negative 2, 4 gets an open circle. And then I'm going to go to negative 3, 5. And negative 4, 6 is right there. So then I want to go ahead and connect those, and that's going to go left forever because it's got the less than symbol. Just like that. The same thing on number 2. I'm going to plug in my numbers. I have 2/3 times 3, which is going to give me 2. Then I have 2/3 times 6, which is going to give me 4. On this one, we pick numbers that are multiples of 3, so it'll be easier to divide. If you have to do this on the final, you will have to come up with your own numbers. So I plugged in 9, and I got out 6. Then over here, all of them will equal 3. So no matter what I plug in, I get out 3. Now I'm going to go ahead and graph them. So for my first one, I'm going to get, this one gets the closed circle because it has the line underneath. So I'm going to go over to 3, 2. Then I have 6, 4. And my 9, 6 is, 6, 4 is right there. 9, 6 is off the graph. But this is linear, so I don't need to have all 3 points. Just want to go ahead and connect my points. There you go. And it goes right forever. Then my other one is going left forever. So at 3, 3, this gets an open circle. And then every point after that is going to be equaling 3. So I'm going to just draw my line. And it should be a straight across line. This one, I get to come up with my own values. I want x's greater than or equal to 0, so I'm going to do 0, 1, and 2. And then my y value is just my x value. So I'm going to have 0, 0, 1, 1, 2, 2. Then over here, I'm doing less than 0, so I'm going to still pick 0, and then I'm going to count down. So I'm going to do negative 1, negative 2. So negative 0 is 0, negative 1 is 1. Negative 2 is 2. So now I want to go ahead and graph this. 0, 0 gets my filled in circle, because this one has the line underneath. Go up to 1, 1, 2, 2, and this goes right forever, so I'm going to go ahead and connect those. Then over here, I again start at 0, 0, but then I have negative 1, 1, and then negative 2, 2. So then I want to go ahead and connect those. For my final one, I'm picking my own numbers again. I want x is greater than or equal to 1, so I'm going to do 1, 2, 3. I'm going to plug in, so I'm plugging in for negative 3x plus 1. So I have negative 3 times 1 plus 1. Negative 3 times 1 is negative 2, plus 1 is negative 1. And I have negative 3 times 2 plus 1. Negative 3 times 2 is negative 6, plus 1 is negative 5. Then I have negative 3 times 3 plus 1, which is negative 9 plus 1, which is negative 8. Over here, I'm doing x is less than 1, so I'm going to plug in the point I care about, and then I'm going to count down. So I have 1, 0, negative 1. Then I'm going to do 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1. And then 2 times negative 1 plus 1. 2 times negative 1 is negative 2, plus 1 is negative 1. So I'm going to go graph these ones. I start off with a filled in circle, so I have 1, negative 1. Then I have 2, negative 5. And then it's going to keep going down, so it doesn't matter that my next point is off the screen, because this one again is linear. I only need 3 points when it's quadratic. Over here, I'm going to graph my first point. It's at 1, 3. This one gets an open circle because it doesn't have the line underneath. And then I go to 0, 1, and 1, negative 1. So now I want to connect those with an arrow. Moving on, this one wants me to graph these and state their domain, range, where they're increasing, decreasing, my vertex and axis of symmetry, and my transformations. I am going to actually start off with my transformations. This 1/2 means it has a vertical shrink of 1/2, or a vertical compression. And the -3 means it's going right 3. So instead of starting at my origin, it's going to go over 3. And instead of having a slope of 1, it's going to have a slope of 1/2. So I'm going to go up 1 over 2 in both directions because this is an absolute value function, and they always look like these. My domain is all real numbers, so that's going to be written as negative infinity to positive infinity because I can plug in anything for x. My range, I have a minimum y value, so I use a square bracket. This is 0, and then it goes up forever, so it goes to infinity. My increasing is where it has a positive slope. So if I take a look at this, I have a positive slope right there. So that starts at 3 and goes on forever. And I'm only looking at my x values when I write this out. And my next one is decreasing. So this is where it has a negative slope. This starts at negative infinity, and it ends at 3. My vertex is where it changes from increasing to decreasing. That is, 3, 0. And my axis of symmetry is where I can cut this in half. That is going to be x equals 3. So same thing for this next one. I am going to start by talking about my transformations. This negative means it's a reflection across the x-axis. No, Yeah, across x-axis. The 5 means it goes left 5, and this 4 is outside, so it goes up 4. And I want to go ahead and graph this, so I'm going to go left 5, up 4, and then instead of opening up, this is going to go down. So my domain for absolute value functions is still negative infinity to positive infinity. My range, I can go down forever, so I'm going to have negative infinity, but I have a high point at 4, and it can include that, so I use a square bracket. Increasing, again, is where I have a positive slope, so that's from negative infinity up until this point, which is at negative 5. Decreasing is a negative slope, which right here, it starts at negative 5, and it goes to infinity forever. My vertex is where the point changes. That is negative 5, 4. And my axis of symmetry is that x value. Same thing here. My domain is negative infinity to positive infinity, because it's an absolute value. I want to talk about my transformations first. I have a vertical stretch of 2. I'm going right 3, opposite the sign, and then down 4. So I want to go ahead and graph this, right 3, down 4. And my vertical stretch of 2 means I have a slope of 2 now. So I'm going to have a positive and negative 2. My range, it's negative infinity to, wait, I did this upside down. This is a positive 2. So like that. It should be V-shaped when it's positive. My range is going to be, my low point is negative 4. And my high point is infinity. Increasing is where it has a positive slope. So this starts at 3 and goes on forever. Decreasing is where it has a negative slope. So this is at negative infinity to 3. My vertex is this point right here, which is 3, negative 4. And my axis of symmetry is that x value. So my final question on this one, I have a vertical stretch of 2. And I'm going down 4. So 1, 2, 3, 4. Vertical stretch of 2 makes my slope of 2. My domain is negative infinity to positive infinity. My range starts at negative 4 and goes up forever. It includes the 4, so I put the square bracket. Increasing is positive slope. So that is starting at 0, going right forever. Decreasing is where I have a negative slope. This is negative infinity to 0. My vertex is where it makes that change. It starts at 0, and then the x value is 0, and then my y value is negative 4. And my axis of symmetry is going to be x equals 0. Okay, moving on. This one wants me to decide if it's arithmetic, geometric, or neither. And then if it's arithmetic or geometric, find the common difference or the common ratio and write the formula. So I want to see the pattern for how I'm going to my numbers. To go from 4 to negative 20, I can subtract 24, but that doesn't seem to be how I get from negative 20 to 100. So I can also go here by multiplying by negative 5, which seems to carry through for all of these. So my common ratio is negative 5. And then to write this as a geometric sequence, it's going to be a sub n equals, my first term is 4, times my common ratio of negative 5, n to the first power. Okay, so this next one, I want to take a look. To go from 15 to 5, I can subtract 10, or I can divide by 3. To go from 5 to 5/3, I keep dividing. So my pattern here is to divide by 3. It means my common ratio is going to be you always write your common ratios as multiplication things. So I actually am going to have this as 1/3, because fractions are the same thing as division. And I'm going to write out my formula. A sub n equals my first term, which was 15, times 1/3 to the n minus 1 power. Over here, to go from 1 to -2, I can multiply by -2, and I can multiply by I can't multiply by -2 to turn into 3. I could subtract 3, but then the pattern here is adding 1. So this one is neither. Next one, it looks like I'm subtracting 7. My next term I am, so my common difference here is -7. Then to write this formula, I'm going to have a sub n. My first term is -18 plus, my common difference, which in this case is negative, so it's actually going to be minus, n minus 1. The formulas you need are down below, by the way, in case you were wondering where I was getting these from. On the next one, I go from 1 to 8 by adding 7 or multiplying 8 to 8 to 27. I add 19 or I can't multiply. So this one is neither. Over here, to go from 9/4 to 5/2, it might be better for me to write these as fractions over 4. So 5/2 is the same thing as 10/4, and 3 is the same thing as 12/4. So what I'm really doing here is I'm adding 1/4. So my common difference is 1/4. And my formula is going to be a sub n equals my first term, which is 9/4, plus 1/4 times n minus 1. My next one, I go from -3 to -27. I can do this by multiplying by 9, which I continue the pattern to go on. So this one is a common ratio of 9. Then to write this out, I'm going to have a sub n, my first term, and then in parentheses 9 to my n minus 1 power. My next one, I am again going to write these as fractions over 2 to make it a little easier. So this is going to be -10 over 2 and -24 over 2. So to go from -10 to -17, I subtract 7/2, and then I subtract 7/2 again to go to -24. So my common difference is going to be -24 over 2. And this one is going to be a sub n, my first term, which is -5, minus 24/2 times n minus 1. This next one, I subtract 60, or I divide by, 100 divided by 40 is 2.5, so I divide by 2.5, because it doesn't look like I'm subtracting 60 here. So I'm going to do 40 divided by 2.5, which gives me 16. 2.5 is the same thing as 5/2. So I have a common ratio, because I'm multiplying, of 5/2. You always want to turn it into a fraction. And then I have a sub n equals my first term, which is 100, times 5/2 to the n minus 1 power.